In this video, we are going to explain about project titled Deep Learning Detection of Electricity Theft Cyber Attacks in Renewable Distribution Generation. The project addresses the issue of electricity theft, which has resulted in financial damages for electric utility companies globally. In past, electricity theft mainly involved the physical methods like tapping into power lines or tampering with meters. However, with the advent of smart grid technology, a new type of electricity theft attacks have emerged, including those prepared through cyber means. The main objective is to put forth a method that utilizes the deep learning to identify the instances of electricity theft within the smart grid. This approach involved the training a deep learning model using a CADA meter readings and PV energy generation profiles to differentiate between legitimate and fraudulent electricity consumption patterns. The primary objective of this research is to showcase the efficacy of this proposed method in detecting the different forms of electricity theft attacks, encompassing the cyber attacks targeting the smart grid. These are the basic requirements that are needed to build this project, that are hardware requirements, operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirements, Python IDEL with version of 3.7. To implement this project, these are the following modules have been designed. The first module is Upload Electricity Theft Dataset. This module allows the users to upload the electricity theft dataset into the application. And the second module is Pre-process the dataset. This dataset is read and process the module. Missing values are handled and non-numeric data is converted into the numeric format since deep learning model only accepts the numeric data. The processed dataset is then split into training and testing part, where the training part is uses of 80% of data and testing of 20% of data. The third module is Run Feed Forward Neural Network. The processed training data is input to the Feed Forward Neural Network algorithm to train a theft detection model. This trained model is then applied to the test data to calculate the prediction accuracy. And the fourth module is Run RNN GRU algorithm. The processed training data is input into GRU, that is Gated Recurrent Unit algorithm, to train a test detection model. Similarly, this trained model is used to make predictions on the test data and calculate the prediction accuracy. And the fifth module is Run Deep Learning CNN algorithm. The processed training data is input into a CNN, that is Convolutional Neural Network algorithm, to train a theft detection model. The trained model is then applied to the test data to calculate the prediction accuracy. The seventh module is Predict the Run extensions of the CNN plus random forest. This module involves the feature extraction from CNN model. The extracted features are then used to retrain a hybrid model using the random forest algorithm. The tested data is then applied to this hybrid model to calculate its accuracy in detecting the electricity theft. And the seventh module is Predict the electricity theft. In this module, the test data is uploaded and the extension algorithm predicts whether the test data represents the normal electricity consumption or contains theft signatures. And the final module is Comparison Graph. And this module is responsible for generating a comparison graph that showcases the performance of all implemented algorithms. The graph helps the visualize and compare the accuracy of each algorithm in detecting the electricity theft. By utilizing these modules, the project aimed to produce a comprehensive solution for detecting the electricity theft. The execution of this project. Double-click on run.bat file. In this screen, click on Upload Electricity Theft Dataset button to upload the dataset, and click on Electricity Theft and click on Open. Here we get that dataset is loaded. In this screen, click on Pre-process dataset and we get a screen like this. In this screen, all numeric data is converted to numeric format. And click on Run Feedforward Neural Network button. We get a raw graph. Here the X graph represents the false positive rate and Y axis represents the true positive rate, and if the blue line comes to this orange line, then we can say that prediction is false, and if blue line comes on top of the orange line, then prediction considered as correct. Now close this graph. We get the accuracy of this network is of 93.97, and click on Run RNN GRU algorithm button. Here x-axis represents false positive rate and y-axis represents the true positive rate of log graph of GRU algorithm, and then close this graph. The accuracy of this algorithm is of 40.59, and click on Run Deep Learning CNN algorithm button, and it gives the CNN raw graph where x-axis represents the false positive rate and y-axis represents the true positive rate, and close this graph. Here the accuracy of CNN is 95.7 and precision is 96.2. And then click on Run Extension CNN plus Random Forest algorithm button. Here the raw graph of extension CNN plus Random Forest. Here the x-axis represents the false positive rate and y-axis represents the true positive rate, and then close this graph and click on Predict Electricity Theft and select the test data from its folder and click on Open. Here in this screen, now in the square bracket we can see the test data, and after this arrow we can see the theft detection as detected as electricity theft and someone not detected as electricity theft. In this way we can detect the electricity theft cyber attack in renewable distributed generation using the deep learning techniques. And click on comparison graph. By this graph we can see that x-axis represents the different algorithms we used in this project and the y-axis represents the values assigned to it. These are the metrics of like accuracy, F1 score, precision and recall, where blue color represents accuracy, orange color represents F1 score, green color represents the precision and red color represents the recall. And then close this graph. This is the exit button where the project has been closed. The project concludes that a hybrid CRNN deep learning architecture is the most effective approach for detecting the electricity theft in renewable energy based DG units. The proposed approach uses a set of cyber attack functions to manipulate the integrity of readings of injected power from the DG units in order to falsely overcharge the electricity utility company. The cyber attack functions include the partial increment, minimum generation, and peak generation attacks. The project demonstrates that the proposed approach can detect various types of electricity theft attacks, including those that involve the cyber attacks on the smart grid.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.